I want you to just imagine something for a second. Imagine you're walking into a small local clinic in your neighborhood.
Okay.
You know the kind of place, right?
Yeah.
Like a few standard exam rooms, maybe a slightly outdated waiting room, magazines from like 3 years ago on the table.
Yeah. I know the exact kind of place you mean.
Right. Now, imagine that the very moment you sit down in that standard exam chair, you suddenly have instant direct access to the exact same cutting-edge genetic and molecular testing as you would at like a top-tier global research hospital in Switzerland.
Wow. That is an incredible image to start with.
It's crazy to think about, right?
It really is, primarily because it highlights, the absolute biggest historical bottleneck in medicine. I
Mm-hmm.
mean, traditionally, the quality of your diagnostic care has been strictly, almost brutally limited by the physical machines sitting inside the actual building you just walked into.
Yeah,
Like,
exactly.
if they don't have a $2 million sequencer in the back room, you just don't get a next-generation sequence.
Yes. And that physical, geographical limitation is exactly what we're breaking down today. So for this deep dive, we're looking into a platform called Detect Lab.
Right?
It's a healthcare technology platform. And basically, it acts as this massive, invisible global bridge between your everyday clinical facilities and, well, the most elite diagnostic laboratories on the planet.
It's a really fascinating system.
It is. And our mission today is to figure out how this platform is democratizing high-end diagnostics, how it transcends borders, and honestly, what it actually takes to safely move incredibly sensitive biological data and physical human tissue samples halfway across the world.
Without ruining them, which is the hard part.
Exactly, without ruining them.
Because the true innovation we're looking at here isn't, some fancy new medical device. I mean, the science, the advanced microscopes, the chemical regions, and all of that already exists.
All right, the science is already there.
Yeah. The real breakthrough is the operational framework connecting that advanced medical science to the everyday patient. Is a massive, incredibly delicate logistical tightrope walk.
A tightrope walk, for sure.
But before we get into the mechanics of how a physical blood sample flies across an ocean, we really need to understand what problem this platform is actually solving for that standard local clinic you mentioned.
Okay, let's unpack this. Because the traditional model for specialized testing just seems like incredibly prohibitive to me.
Oh, absolutely.
Like, if a hospital or a clinic wants to offer advanced genetic screening, they can't just flip a switch, right? They have to buy the physical machines, hire highly specialized technicians.
And manage the ongoing maintenance of all that gear.
Right, and constantly deal with updating their accreditations. I mean, we are talking about a massive capital investment.
Yeah, you're looking at millions of dollars just to set up the baseline lab infrastructure. And that's before you even look at the operational costs to keep it running day to day.
It's just not feasible for a small clinic.
Exactly. And what the Tech Lab does is allow what they call client labs, which are basically those local clinics and hospitals we're talking about, to completely bypass that massive financial hurdle.
So they just skip the whole infrastructure part.
Yep. Instead of buying the physical machines, they just plug into the data ecosystem. And virtually overnight, that local clinic can offer over 500 specialized diagnostic tests.
Wait, 500?
Over 500, yeah, without buying a single new test tube.
That is wild. That completely changes the paradigm. It sounds exactly like cloud computing, but for physical healthcare.
Oh, that's a great way to put it.
Like instead of buying a massive, expensive server farm for your small tech business, you just rent server space from Amazon or Google, right?
Exactly.
Here, instead of buying $1 million genetic sequencing machine, the clinic just rents access to one that happens to be sitting halfway across the world.
What's fascinating here is how that fundamentally shifts the daily reality for these healthcare providers. I mean, it removes an enormous administrative and financial burden right off their shoulders.
Because they don't have to be business managers anymore.
Exactly. Think about it. A doctor went to medical school to treat patients, right? Not to run a highly complex, capital-intensive laboratory business on the side.
Right, right.
By offloading all those infrastructure requirements, they can focus entirely on actual patient care.
And the types of tests we're talking about unlocking here, they aren't just your standard, cholesterol checks or basic blood panels.
No, not at all.
The sources mention precision molecular and genetic analysis, things like PCR testing, NIPT, advanced oncology panels, rare disease screening.
Heavy hitters?
Yeah, the heavy hitters.
Yeah.
So for those of us who aren't, walking around in a lab coat every day, what do those actually entail?
Well, let's break a few of those down because the sheer complexity of these tests is exactly why you need elite labs in the first place.
Okay, laid on me.
Take PCR or polymerase chain reaction. It's essentially a molecular photocopying machine. It takes a tiny microscopic fragment of DNA or RNA, maybe from a virus, and multiplies it millions of times.
Just so there's enough of it to actually see and study?
Precisely. Then you have things like NIPT, which stands for non-invasive prenatal testing.
Right, I've heard of this one.
Yeah, it's amazing. Instead of a risky invasive procedure to test a fetus, scientists can now take a simple blood draw from the mother, isolate the tiny fragments of the baby's DNA that are just floating in her bloodstream, and screen for severe genetic abnormalities.
That is just, I mean, pulling fetal DNA from the mother's blood just sounds like science fiction.
It really does, but it's incredible science. And, the oncology panels are just as advanced. They aren't just looking for cancer in some broad sense.
What are they looking for then?
They sequence the actual DNA of a specific tumor to find its exact genetic mutation. This allows doctors to prescribe a highly targeted therapy that only attacks those specific mutated cells.
Wow.
And beyond genetics, the platform also taps into comprehensive forensics and toxicology, like advanced drug and alcohol management, and even consumer health wellness tests.
Okay, so if the local clinic is the starting point, the endpoint where the patient actually sits, who is on the other side? And who is making sure these two sides actually talk to each other?
Well, an ecosystem is only as strong as its participants, right? And in the Detect Lab platform, there are 3 primary user roles.
Okay, 3 roles.
First, you have the client labs, which we just discussed. Those are the local clinics ordering the tests. On the other end, you have the partner labs.
And those are the big guys.
Right. The elite, heavily accredited facilities globally, they are the ones actually running the complex experiments, doing the genetic sequencing, analyzing the results.
Got it.
But it's the third role that is perhaps the absolute most crucial for making this global network actually function. And those are the distributors.
Okay, I've got to push back here for a second.
Sure.
Because I totally understand why a clinic needs access to a lab, right?
Yeah.
And I understand why a high-end lab wants more global clients to process. That's just good business.
Yeah.
But why inject a distributor into the middle of this relationship? Doesn't adding a third-party middleman usually just, slow things down, complicate the chain of custody, and ultimately make things more expensive?
I mean, if we lived in a completely frictionless world where every single country had the exact same laws and perfect infrastructure, you might be right.
Right. But we don't.
We really don't.
Yeah.
You have to think about the physical reality of global healthcare. A distributor in this ecosystem isn't just some sales rep taking a cut. They are network builders. They are localized problem solvers.
What kind of problems are they solving specifically?
Well, let's look at the friction of moving medical supplies.
Okay.
Crossing an international border with biological tissue is an absolute logistical nightmare.
I can imagine. I mean, customs agents probably don't love unmarked vials of blood just showing up in a cardboard box.
Exactly. Imagine trying to get a highly time-sensitive tissue sample out of a rural clinic in Kenya, or, navigating the incredibly specific import-export regulations for biological materials in Malaysia or the Philippines.
That sounds like a massive headache.
It is. A centralized tech company sitting in a sleek headquarters in Singapore cannot manage the ground-level logistics of a courier hitting a washed-out dirt road in Nairobi or a sudden customs holdup in Dubai.
Oh, I see.
The local distributor understands the roads, the local couriers, the customs regulations, and the local hospital networks far better than an elite lab in Europe ever could.
Okay, so they are essentially the boots on the ground, making sure the physical reality actually matches the software's promise.
Precisely. The Tech Lab uses what they call the Exclusive Country Partner Program. And what this does is it allows these regional distributors to white label the platform.
Wait, so they put their own name on it?
Yeah, the distributor integrates this cutting-edge software with their own local brand identity, tailored precisely to their region's specific operational rules.
Oh, that's smart.
And in return for managing all that real-world friction, they get unrestricted regional exclusivity and 100% revenue ownership from their local clinical partnerships.
Wow, so everybody wins.
Basically. It creates a thriving, self-sustaining diagnostic ecosystem in regions that, frankly, desperately need access to these kinds of tests.
Okay, that makes a lot of sense. So we know who the players are now. We've got the local clinic treating the patient, the local distributor greasing the wheels and handling the red tape, and the elite partner lab waiting to do the deep science.
Yep, the whole trio.
But here is the multi-million-dollar question for me. Let's follow a single sample.
Okay, let's just do it.
How does a physical drop of blood actually get from a patient's arm in a clinic in Kenya all the way to an elite partner lab in Switzerland without completely degrading? Because, I mean, we aren't shipping a pair of sneakers here.
No, we absolutely are not. Biological matter is incredibly fragile. Time and temperature are the ultimate enemies of accurate diagnostics. If a sample gets even slightly too warm, the proteins denature, the DNA degrades, and the test becomes entirely useless, or worse.
It gives a false result.
Exactly, which is dangerous.
Yeah.
So this is where the decoy process comes in, turning what used to be a really chaotic, unpredictable supply chain into a highly controlled, continuous journey.
Here's where it gets really interesting for me. Because when you look at how they manage this, it's essentially an ultra-high stakes ride-sharing app.
That's an interesting way to frame it.
Yeah, but instead of moving a person from point A to point B, it's transporting fragile biological matter where a single temperature drop could literally ruin a critical oncology screening.
Right.
So walk me through the journey of that blood sample from Kenya.
Okay, so it starts at the clinic's dashboard. The doctor has already effortlessly selected the exact test they need from the portfolio.
Okay.
And crucially, before they even draw the blood, they see complete transparency, upfront pricing, and the exact turnaround time.
So there are no surprises.
Right. So the blood is drawn. Immediately, the platform orchestrates the physical pickup by deploying professional, vetted local couriers. And this is where we hit the most critical phrase in global diagnostics: strict cold chain integrity.
Now, I've heard that term thrown around a lot since the pandemic, with the vaccines. But what does maintaining a cold chain actually look like in practice for just a single vial of blood?
It's actually really complex. It requires a flawless orchestration of specialized hardware and software. The sample isn't just, tossed in a styrofoam cooler with some dry ice.
I would hope not.
Right. It is packaged in highly specialized containers, utilizing vacuum insulation and phase change material.
Phase change material.
Yeah, they're substances that actively absorb or release thermal energy to maintain an incredibly precise temperature. And more importantly, these packages often contain continuous data loggers, which are little IoT Internet of Things sensors.
Wait, so the package itself is actively communicating with the network while it's physically in transit?
Yes. From the exact moment it leaves the clinic in Kenya, through the international flight, through customs, all the way to the lab bench in Europe, it is actively monitored.
That's amazing.
If the temperature drops or spikes by even half a degree, the system immediately knows. If we connect this to the bigger picture, the integration of this real-time monitoring at every single stage is what actually makes the whole global business model possible.
Because there's no blind spot.
Exactly. The clinic can track the sample, just like you track a food delivery, but with infinitely more critical data attached to it.
Man, that mitigates so much anxiety for the doctor and the patient. You aren't just blindly hoping it makes it. You know exactly where the tissue is and what condition it's in.
Absolutely.
So our sample survives the flight. It passes customs thanks to the local distributor, and it arrives at the partner lab. Now, the sources mentioned these labs require CAP and ISO certifications. Why does that matter so much?
Well, because you need absolute certainty that the lab halfway across the world is operating to the highest possible standard. You're trusting them with a life.
Right.
CAP stands for the College of American Pathologists, and ISO refers to the International Organization for Standardization. And these aren't just like participation trophies you hang on the wall.
They're rigorous.
Very. To get CAP certified, a lab has to undergo rigorous, unannounced inspections and participate in continuous proficiency testing.
What does that mean, proficiency testing?
It means CAP will send them blind samples to test, just to prove their machines, and their technicians are actually getting the right answers on a daily basis.
Yeah.
It is the absolute gold standard for laboratory quality assurance globally.
Okay, so our Kenyan blood sample is processed by a top-tier CAP-certified lab in Europe. The sequencing is done. They've found the genetic marker.
Yep.
Now they have to get that highly sensitive diagnostic result back to the clinic's dashboard in Kenya instantaneously.
And that right there brings us to the most invisible, yet arguably the most legally perilous part of this entire ecosystem.
I can imagine.
Yeah. We've successfully navigated the physical logistics of moving matter across the globe, but Moving the resulting digital data back across those borders is, in many ways, an even greater challenge.
Seriously, I mean, data privacy is an absolute nightmare to manage within just one country's laws.
Let alone globally.
Exactly. The United States has its rules, Europe has entirely different ones. So how on earth does a platform guarantee compliance when a sample taken from a patient in the UAE is flown to a lab in Europe, and then the data is beamed back to a distributor in a third country?
It sounds impossible.
Right. You are triggering entirely different, sometimes completely conflicting legal frameworks all at the same time.
This raises an important question about the fundamental architecture of modern healthcare tech. You cannot treat security as an add-on or a patch you just install later.
It has to be baked in.
Exactly. The Take Lab's entire system is built intrinsically around overlapping global standards. The trifecta they navigate is HIPAA from the United States, GDPR from Europe, and PDPA, which is the Personal Data Protection Act used in places like Singapore, where DateTech is headquartered.
But wait, don't those laws sometimes clash?
How do you mean?
Well, like, Akai is heavily focused on making sure your health data can be safely ported between your different doctors, right? While the European GDPR is heavily focused on the individual's right to total privacy, including, the right to be forgotten and have their data completely erased.
That's a great point.
So how do you satisfy a mandate to share data and a mandate to lock it down at the same time?
You do it by basically implementing the strictest common denominator across the board
Yeah.
and separating the medical data from the personal identity wherever possible.
Oh, interesting.
It starts at the foundational level with the encryption. They use fortified AES-256 military-grade encryption.
Okay, I see AES-256 advertised on my personal VPN all the time. But is that actually robust enough to protect someone's raw DNA sequence from being hacked?
Oh, it definitely is.
Yep.
AES-256 is the cryptographic standard used by intelligence agencies to protect top-secret information.
Wow.
It means the data is scrambled into an unreadable cipher, both when it is at rest, meaning it's sitting on a hard drive on a server somewhere, and in transit, meaning when it's actively being beamed from the lab in Europe back to the clinic in Kenya.
So it's locked down the whole time.
Yeah, even if a bad actor intercepted the data packet mid-flight, it would literally take modern supercomputers millions of years to crack that cipher.
Okay, so the outside hackers are blocked. Good to know. But what about internal leaks? Like, the person working the billing desk at the local clinic does not need to see the specific genetic markers of a patient's oncology report, right?
Exactly, and that is where they bridge the gap between HIPAA's need for care coordination and GDPR's strict privacy rules. They use precision role-based access controls.
Which means?
The system uses highly sophisticated permissions to ensure that healthcare professionals only see the exact information they absolutely need to perform their specific job function.
Oh, I see.
So the lab technician in Europe might only see an anonymized barcode and the raw biological data they need to analyze. They have no idea what the patient's name is or where they live. Meanwhile, the treating physician in Kenya sees the full clinical picture.
That makes a lot of sense. You just limit the exposure surface.
Exactly. And to back all of this up and to actually prove to regulators that they are following the rules, the platform utilizes transparent audit logs.
Let me guess. That's basically a digital, unalterable paper trail for the data.
Perfectly stated, yes. Every single time anyone, anywhere, interacts with the system, whether it's a courier logging a temperature check, a lab tech uploading a sequencing result, or a doctor opening the final PDF file, that action is time-stamped and permanently recorded.
They can't hide anything.
Nope. Those transparent audit logs and the role-based access essentially act as the ultimate compliance mechanism. Whether an auditor is looking at it and through the lens of European GDPR or American HIPAA, the system can undeniably prove exactly who touched the data, when they touched it, and how it was protected. It guarantees patient confidentiality, regardless of the geographical borders the data just crossed.
So what does this all mean? When you zoom out and look at all these moving parts, the local clinics, the elite partner labs, the local distributors managing the real-world friction, the IoT cold chain logistics, and the military-grade encryption reconciling global privacy laws, you see a total transformation of the diagnostic landscape.
You really do.
What used to be a highly fragmented, incredibly expensive, and, locally limited process is now a streamlined, globally accessible ecosystem.
It is empowering local clinics in emerging markets like Malaysia, the Philippines, the UAE, and Kenya to offer world-class care without going bankrupt buying equipment. It is building entirely new, scalable businesses for regional distributors who actually understand the logistics of their local markets. But most importantly, It is drastically speeding up life-saving, accurate diagnoses for patients who previously would never have had access to this level of medical science.
Because at the end of the day, all of this tech, all of this crazy logistics is really just about that person sitting in the standard exam chair we talked about at the very beginning.
That's the core of it. It's vital to remember that the next time you visit a doctor, the quality of your care might no longer be dictated by the four walls of that specific building you just walked into.
It's way bigger than that now.
Yeah. Behind the scenes, there could be a massive, invisible global network working to ensure you get the absolute best diagnostic expertise available on the planet, seamlessly routing your samples and data to whoever is best equipped to handle them.
It really makes you rethink what a hospital actually is. We started by imagining walking into a small local clinic, but really, that clinic door is just becoming a physical portal to a decentralized global medical network.
That's a great way to look at it.
Which leaves us with a pretty wild thought to chew on as we wrap up.
Oh, yeah?
Yeah, if a digital platform can seamlessly and securely route our most sensitive genetic material, our blood, and our private health data around the world just to find the absolute best diagnostic expertise,
Right.
how long before the medical treatment itself becomes entirely decentralized and borderless?
Now, that is a truly fascinating frontier.